Today I'll be talking about the XP range of coils and explaining to you where to use them and when to use them so you get the full benefits. But to begin with, I'm going to show you the latest innovation from the XP, where you can fix the coil to the bottom stem. It's a new simplified version. XP have improved the method for attaching the coil to the bottom stem, and it all hinges on this plastic insert. The hole has been enlarged to 10 mm to be able to slip in the plastic insert. So now you only require one washer on that far side. One bolt, one wing nut, and it's complete and it's more rigid. For all of you out there who have the older style coil, there is a kit you can buy and you can have that retrofitted. All you need to do is drill the 10 mm hole this side. The instructions are inside. Right, let's go on to the other coils and the conditions where we use them. Right, so what I'll be doing is making a small test bed using these coins. We've got a Victorian Penny copper, Celtic silver minim, a Roman antiquarius, a Roman silver denarius, a Celtic silver stater, and a cut half of medieval silver. Right, we'll start with the 18 kHz elliptical coil. A lot of people think this is too small. Where you will use this is on highly mineralized ground or on real iron contaminated sites. A lot of people think you don't get the depth. Well, I've buried these coins and we'll just run through and just show you the capabilities of this little coil. We'll start with the minim. This is the Celtic silver minim, which you've seen before, and this is at a depth of about 3 inches. And we move on to the cut half, the hammered cut half, and that's at 4 inches, loud and clear. We move on to the denarius. We've got this around about 5 to 6 inches. Still coming through clear. We move on to the silver Celtic unit. Once again, still coming through. We move on to the antiquarius, but this is at a depth of around about 4 to 5 inches. Still looking good. And we move on to the Victorian Penny. This is around about 9–10 inches maximum. It's struggling, but it still gets it. So have no fear about not having any depth on these little coils. No, sure, it's not as great as the 11-inch, but we'll move on to them now. Right, we'll now use the new ADX 150 4.6 kHz with the 9-inch coil. Now, I've said before in the past about the 18 kHz being really good on small objects. Don't be surprised if you find that the 4.6 with a 9-inch coil don't pull that very, very tiny minim at that depth. It'll pull it if it's just underneath the coil, sure, but at that depth, don't be surprised if it misses it. Which it duly has done. But we'll move on to the cut half, which is no problem. The denarius coming through, the silver stater, and then moving on to the antiquarius. And finally, the copper penny. So apart from the little Celtic minim, everything else was fine. But now we'll try it with the 4.6 11-inch coil. Right, we've now moved up to the 11-inch wide scan. Still using the ADX 150 at 4.6 kilohertz. The wide scan coil will handle mineralisation better. It will also recognise iron far easier than if you're using a concentric coil. Also with the lower frequency 4.6 as opposed to the 18 kilohertz. Right, let's see how it gets on. This is the little Celtic silver minim. That little piece over there was iron. So you've got nothing there at the moment. The cut half has come through loud and clear. Denarius even more so. Moving on to the silver stator. Chopped to begin with, and then when you're really over the target, it comes through loud and clear. The Antoninianus, no problem, and I don't think this is going to pose any problem. Even at that height, because that's the beauty of the wide scan and lower frequencies. It's going to find those thicker targets deeper. Now we come to the largest coil in the XP range, the 18 by 15 wide scan, the double D. You see the D and the D. These won't be effective over mineralised ground or very naily areas. The tiny coinage could slip by on something like this. This is more effective on the larger, thicker items. Let's see how we get on. This is the silver Celtic minim. And as I suspected, nothing whatsoever. So we'll move on. This is the cut half, hammered cut half, silver. Coming through. We'll move on to the Denarius. Now this is slightly thicker, so I expect something better. Although it's deeper than that, this is a thicker coinage, and it's pulling it loud and clear. So it should do the same on this Celtic silver unit. Once again, loud and clear. Antoninianus, and this is bronze. And now moving on to the copper penny. This is 30 millimeters across, this penny. And look how high I can pull the coil. Even at that height. This will find the larger items at depth. We're talking hoard or bigger items than the copper penny and upwards. The smaller stuff, no. This isn't meant for that. On the normal coinage, we're talking like denarius and status size, you will get the same depth as the 11-inch core. But there's going to be very little difference in it. This is more for ground coverage and your bigger items. So now we've moved on to the concentric call. We're using that on the Gold Maxx Power 18 kilohertz. This is really what it's meant for. If you look at the coil, it is different from the wide scan. You've got the outer ring, this is the send, and you've got the inner circle, this is the receive coil. And this is brilliant for pinpointing. It's very, very sharp on small objects. And I think you're going to be really surprised when we start going over the tiny objects like the little silver minim, the little Celtic minim. Let's give it a try. Really sharp when you compare it with the other signals. Move on to the cut half. Once again, thin sectioned. Lovely signal. Denarius. Beautiful. Move on to the Celtic silver unit. This is thicker. Once again, good. Antoninianus, which is bronze. once again good. I know we're going to struggle slightly on this copper penny because it is at depth. And there you can have the difference between a wide scan, 4.6 kilohertz, which is good on the larger, thicker objects, than a concentric 18 kilohertz, which is good on the very small, high conductivity items. Listen again. And when you compare that with the 4.6 kilohertz, and that's the concentric core.